Daryl here. The channel is Programming in Any Language. The supporting website is programminginanylanguage.com or black-duck.com. They both take the same place, and it's a place where you find the videos and PDFs of the code. You can download those. The video is Abstraction. As you'll soon see, abstraction is a way of defining a checklist and properties and methods that belong to several sets of objects you need to define. Basically, you create an abstract class which is never intended to be instantiated. In fact, it can't be. But once you create it, you use it for the basis of several derived classes which it will be instantiated. In our video example, we're going to define an abstract class based on recreational vehicles. We won't instantiate the class. Rather, we'll derive three classes that share the properties of the base class. We'll set up the large Class A motorhome as one of the derived classes. We'll also set up a Class B motorhome, which is actually a converted van. The Class C motorhome is based on a truck frame. All three have similar characteristics found in the base class, but are very different vehicles. Let's watch that video. We're getting down to near the end of the big words we use in object-oriented programming, and this one isn't quite as big, really, as some of the other ones were so far. And I consider this more of a checklist type of programming procedure that we're going to be looking at. It's called abstraction. And abstraction is what we're going to be taking a look at next. Not that big word. A class that is not intended to be instantiated, but is to be used only as a base class, is called an abstract class. An abstract class serves a base class, but is not instantiated itself. So you wonder why. Okay, an abstract method has no body. It must be overridden in a derived class. Abstract classes basically they're the starting point that you might have when you're trying to create classes. In fact, they form a very good checklist, as you're going to see as we go through this. Abstract classes are created when it doesn't make sense to instantiate the class, but it does make sense to instantiate derived classes based on the abstract base class. An abstract class serves as a base class, but is not instantiated itself. It provides a starting point, providing some class members to its derived class. An example might be a company that manufactures three types of recreational vehicles: Class A motorhomes, Class B motorhomes, and Class C motorhomes. The Class A are self-contained homes on wheels. The Class B are self-contained homes customized on a van. And Class C are self-contained homes built on a truck frame. Basically, it kind of looks like this. We have an uninstantiated base class, which is basically RVs in general. There's things that are common to the Class A and Class B and Class C type of RVs. And we can put those in the uninstantiated base class, but never create a class from the base class because we don't have a generic RV of that type. Instead, we have Class A, Class B, and Class C. All three RV types share features, but there's no such thing as a generic RV. Take a look. We've got Class A, B, and C in here. We've got price ranges of $50,000 to $30,000, $300,000 for a Class A, $50,000 to $150,000 for Class B, and $100,000 to $150,000 for Class C. Length is different too. Class A's are 21 to 45 feet. Class B's are typically 17 to 23 feet, and Class C's are 20 to 33 feet. The capacity is 4 to 8 people in a Class A, 2 to 4 people in a Class B, 4 to 8 people in a Class C. The pros are large, luxurious living, and the Bs are easy to drive. Class Cs are friendly. Cons are difficult to park, limited storage space, higher starting cost than the Class B. So those are things that are different there. And when you want to look at these things, you want to look at three very different types of RVs: the Class A, the Class B, and the Class C. Now, if you look at this in the RV example, the base class is not intended to be instantiated. It is there for the purpose of providing an outline for the subclasses. A base RV class would contain what is common to all RV types. The Class A class can be derived from the base RV class, and override properties that are unique to the type A RV. Take a look. To declare a class as abstract, we use the abstract keyword in the class header. You can see we have abstract class base RV, we're calling it. And inside it, we have the base RV. We have a model and a classification that we want to hang on to in the constructor. And we've got a bunch of concrete properties and abstract properties going forward. We have the model and classification are concrete properties because we're not going to override them. We can use them as is. We can use these things as is in our derived class. The abstract properties of base price, max capacity, min length, max length are all going to be overridden when we get to the point of actually creating the subclass. And you can see we have also public abstract string modify classification. We have a method down here that's also an abstract method, which must be overridden. The abstract keyword indicates the class is intended to only be a base class of other classes. It cannot be instantiated. An abstract class can have abstract and concrete members, as you can see. The model classification, again, the gets and sets are there. We're going to bring in a model, we're going to bring in a classification, and it'll be complementary if we're using Class A, Class B, or Class C. But the base price is going to be very different for Class A or Class B or Class C. The max capacity is going to be different. And so we put those things in there. They're part of our checklist in our initial class, but we're going to use them differently when we go to the three types of RVs we're creating. Abstract members must be overridden in the derived class. To make them read-only, we leave out the set accessor. And you can see that the abstract properties all have just gets and not sets. Abstract properties appear in the base class. Abstract properties are expected to be overridden in a derived class. And here is a derived class. The class A is based on the base RV. The subclass class A is derived from the base class. Constants common to the class A type motorhome are identified at the beginning of the code. We have the base price, $100,000, the capacity 8, min length 21, max length 45. And then we create the class A derived class, bring in the model and classification. Now that classification equals classification, we can leave that there, or we can not have it there. We can even put model equals model in here as well. It doesn't matter too much as long as you've got them up in the beginning of the public and you're bringing them from the code itself, because it'll get used there and it will become available to the subclass. We do have the properties sitting here, and you can see public override, double base price, get return base price. It's going to return the base price, which we got from our constant up on top. So a calling program will grab that $100,000 and paste it for us, put it out there. You can see that it's the same thing with max capacity, min length, max length. And then we have a proper override of modify classification. And we have classification. This is a large scale motorhome. We're actually overriding the classification done in the constructor up on top. And we'll be doing it differently for each one of the classes we create, the Class A, the Class B, and the Class C motorhomes. And you can see here, line 17 retrieves the model and classification from the instantiated of Class A class. And on the left side, you can see the code that we use to actually access the model equals tx model.text. We're bringing in the model from the text box from the customer. And we're looking at radio buttons. If rad class A has been checked, then we're going to say our classification equal to class A. And then we're going to create an instance of the class A object, which is based on the base RV. And it's going to bring in the model and classification. Then we're going to grab the base price, max capacity, min length, max length, and put them in labels with those get properties we're seeing in the Class A class. Then we're taking RV Class A modify classification. We're actually using that method to change the classification to some verbiage that we're going to print on our label. And LBL classification text is RV Class A classification to strings. We're taking our classification, which has been changed now, and putting it out onto the form itself. Line 19, by the way, as you can see there, classification equals classification. Line 19 could remain blank. It could also add model equals model to the code. It doesn't matter, as model and classification are base properties. And I tried it both ways. I tried it with or without, and it works the same. The four abstract properties are read-only, as the base class include only the get accessor when designed. And you can see we're bringing those in from that class A, based on the base class, the base RV class. Lines 20 through 35 show overriding properties returning the value of the constants to the calling code. Abstract classes can contain abstract methods. An abstract method has only a header and no body. It must be overridden in the abstract class. And so we see the method down below has classification equals this is a large-scale motorhome for the Class A. We're going to return classification then to our label. So it's making the change there. Line 37 calls the method and the new classification is returned. This is a look at what we're going to actually do to make this all happen. The RV inventory, where we have a model and the different classes and the data we're going to be dealing with. I've set up the form for the RV inventory to look something like this, as you're seeing here. And each of these things has properties associated with them. We can click on the model up here, and it is a text model that we're actually calling it. The label up here is called nothing but label 1 because we're not going to make any changes to it in code. This is the label called class, and inside here we have 3 radio buttons. Rad class A, rad class B, and rad or radio button class C. Right here we have a label classification, so we're going to be actually put the new classification going to be sitting in here. It's kind of a sentence we're going to create. And then our labels down here, base price is label 3, but inside here we have label base price, label max capacity, label min length, label max length. And of course our buttons, button display data, and button exit. And that's all the changes we needed for this thing. What we're going to do first of all is we're going to create the base RV class. And so we do that by going up in here and adding a class, which we'll call RV class. We're going to call this one base RV and add it. And it gives us our initial code for this particular thing. What we need to do here is we need to change abstract. A-B-S-T-R-A-C-T. We now have abstract class itself, and now it is now an abstract base class. It cannot be instantiated, but it can be the checklist for all the things we're going to be doing going forward. Widen this a little bit. Under our base class, we're going to create the constructor. The constructor is going to look something like this. And in this case, I put in the model and the classification. Model is model, classification, they're sitting there. We have errors right now because I don't have those properties identified. We're going to identify those concrete properties next by placing them in the code. And once they're in place, the errors go away. We have our get and set properties for the model, get and set accesses for the model and classification. We're now going to add the abstract properties. We're going to go something like this. The abstract double base price with a get, no set. These be read only. Abstract int max capacity, int min length, int max length. And these will be all properties. The other thing we're going to do is we want to add a method to this thing, to an abstract method. So we'll do that. Modify classification down here is our method. And that takes care of it. That's all we need. What we've done, though, is we built a checklist for the things we're going to want in our RV. We're going to want a model, a classification. We're going to get a base price of those different RVs, the Class A, Class B, and Class C. Max capacity of minimum length, maximum length. And we're going to have some kind of a override of a classification. We're going to actually put a note here as to what the particular RV type is when we actually get. So that's our base RV. So now all of our derived classes will come from this particular class. And we can go ahead and do that right away. We're going to create the next one, which will be the Class A. So we'll add a new class. We'll call this one Class A. The code is created for this, our initial Class A class. And inside of it, we're going to take this Class A and say we're based on the base RV. So it knows where it's coming from, where that checklist is coming from. And we have an error right away because we don't have all the rest of the pieces in here. We'll do that right away by creating, first of all, we'll put in our constants that we want in here. And then we're going to create our constructor, and we'll create our properties. Now the constructor contains the classification and the model classification are the concrete properties. Now we're going to create the base price, the overriding properties here. And the last thing we want to do is create the override method, which will stick right here. So we're good here. Base RV, Class A is now based on this, and we're all set. This is a large-scale motorhome is the method that we're going to be creating. That's going to be happen when we actually get a base RV. Now, the interesting thing is the Class B RV is very, very similar. And so what we're going to do is we're going to go ahead and create another class. We'll call this one Class B. And because it's almost identical to the Class A, I'm going to go to Class A and steal most of the code and just modify it. So I'm going to go here and grab all this. Go to my Class B, put it in here, and I also want to say it's based on the base RV. And we got to change this to a B. And that pretty much does it for us. This is because we want to call this thing, this is going to actually be a capacitor. We're going to have this thing is $75,000. We're going to have this is going to be a 4. And 17 and 23 are going to be the length. And we're going to say that this is a conversion van or converted van. Right down here. And our Class B is done. We're all set to go with this. Need to get one more. We're going to add the next class, which is going to be a Class C. Go ahead and do the add. Based on the base RV, we get the air. And again, we can grab all the code from Class A and pop it into Class C. Make our change, starting with the method. This is an RV based on a truck frame. This is Class C. And we're going to be calling this thing $95,000. It is going to hold 8, but it's going to be 20 as our length, and 33 is our max length. Everything else can stay. We're in good shape here. And you could do model equals model here without any problems at all. So that takes care of our classification. We've got all those classes here. Now it's going to be a matter of putting the code together to make all this all happen. So we're going to do that. First, I'm going to save everything. We'll click on the exit button. Do that guy first. Then we'll go into our code, what we're actually going to be creating here. So what we're going to do is we're going to go into the display data button. And in here, we're going to create variables to hold data. Our string model and our string classification are going to be sitting out there to hang on to it. We're also going to grab in our model and get it. And we get that from our text box. So that's all there. The next thing we're going to do is we're going to do an if statement. And that if statement is going to look something like this. If right class A is checked, we're going to do these things. And we're going to do the same thing for Class B and Class C as well. But if you look at these things, we're going to be taking the Class A, putting in classification. We're going to instantiate the RV Class A as a new Class A with model classification coming in. We're going to then grab the base prices from our Class A derived class and assign them to our label coming out. Then we're going to run the modify classification method from Class A's class and change our Class A to a comment saying expensive motorhome or something of that nature and have that sitting in here. That's all we need to do. Then we're going to do the same thing for the other ones that are sitting down here. So basically we're going to say else if rad Class B is checked. Do the same thing but Class B, and we're going to do the same stuff, grabbing the Class B motorhome and bring in these labels. All the Class B information's here. And then finally, we'll do a final else right here. Bring in the Class C. And those three things. So this code is identical from A, B, and C, other than the fact that it's saying A, B, or C when you get into it. And that's all you need to do to make this thing work. So we're going to save it. We're going to run it. Well, we can call this thing Black Beauty as our model number. We're selling the Black Beauty RV. P-E-A-U-D-Y. And it's going to be a Class A, so we're going to put display data. Notice it brings in the data we had in our code, in our class itself, which you can see right here. Brings all this data in, and then it goes ahead and labels it. In fact, let's do it like this. This looks much better. We can kind of see it. It takes in the 100,000 we have the property, as the 8, the 21, and the 45 are coming down here, and then we're displaying our data, but we're also, this is a large-scale motorhome coming in here, which is bringing up this method is actually running here. If I change this to a Class B and hit display data, the numbers change. This is a converted van, $75,000. 4 is the max capacity, 17 and 23. Go to Class C, display the data. This is an RV based on a truck frame, 95,000, 8, 20, and 33. So what you're seeing here is we have a base RV with, as a checklist that we're going to need. We're going to need a model classification. These are going to be standard no matter what thing you're actually bringing in. But you're going to have specific amounts for these guys down here. So you set them up as it gets and sets. You don't have to do this. This is just a nice way of being able to establish something that you're going to have no real instantiation of a base class, and instead you're going to be instantiating subclasses that are going to be meaningful for your particular program. And then you end up with, of course, this guy right here, and we're good to go. Once again, the Traveler. Call it that. Make it a Class B. Hit it, and bang, we've got ourselves. So that's basically it, and that's really all we're talking about when it comes to abstraction. You're simply hiding a checklist and then using that checklist to create subclasses that are based on that checklist, and that's on the checklist you got up on top. So that's all there is to it. That's basically how to do abstraction in a nutshell. As you can see, there is a place where abstraction could be valuable. I like the idea of the checklist. You define a series of properties that you need and list them. As you build the derived classes, all you need to do is override the abstract properties and methods. Thanks for watching. Visit the website when you get a chance, and please subscribe to the channel. There's something new coming every week. We'll see you in the next video. Take care.